Okay, and what you see on the screen is using limits to find the slope of tangent lines. And you may remember at the beginning of the semester, I introduced this idea actually when we were doing conic sections and we were finding tangent lines to parabolas. Does anyone remember there were 3 ways to do that? So I had like a parabola. Here's y equals x squared parabola. And here's the point, 39. And there was a tangent line. And we had 3 different ways. And like on test number 1, we would have, I maybe had a question on this. Anyone remember what any of the 3 ways of finding the slope of a line tangent to a parabola is? You can type it, you can unmute and say it. It's up to you. Okay, well, people may not remember, but that's okay because we're going to go over. Well, derivative is sort of the official name for what we did. Let me bring a Desmos screen up for you. Hold on a second. Let me just get the Desmos up. Here we go. Oh, here's a couple more people coming in. Okay, Ethan brought up there was a way of, yes, there was a way of a limit if something approaches 0. Here, check this out. This animation explains really well what the insight is here. There are some people coming in now who I haven't seen in a long time because they haven't been able to come to any of the 10th period ones. So welcome. Here's the idea. So I have here a parabola, and if I move this point A around, you see the point moves and the tangent line moves. That's why line has a slope, but a curve doesn't have a slope. It depends on where on the curve you are. The tangent line can have slope. And the insight was this. You can't get the equation of a line or the slope of a line if you only know 1 point on it. But if there were 2 points, so here are 2 points. And you can see I have 2 lines also. I have the tangent line, but I have this other line that actually joins those 2 points. Well, that line is called a secant line, just like in a circle. If it hits 2 points, it's a secant line. And the secant line slope is close to the tangent line slope, but it's not exactly. But if h was smaller, the smaller h gets, the closer the red point gets to the blue point. And then you can see that secant line gets closer and closer to being an actual tangent line. And when h actually becomes 0, it becomes the tangent line. And we learned this, at least for this case, for the parabola, but now we can, with limits, we can do, we can go into some other curves. So let me bring the iPad back up. Now here's a real specific, we're going to do a specific example and then a general example. So for the parabola, it's y equals x squared. And we have this point, which is 3, 9. That's the point of tangency. So what I do is I pick another point. That other point is not on the tangent line. It's actually on the parabola itself. If I exaggerate this picture, you know, you clearly see that let me exaggerate it even more than that. If it was like that, and I use this point and that point, you'd be able to see that the secant line is not the same thing as the tangent line. Well, the other point is a little bit to the right of the first point. And we call the difference in the x values, we use the letter h for that. So this other point is not 3, 9. It's 3 plus h is the x coordinate. Now this point is not on the tangent line. It's on the parabola itself. So what would the y coordinate of that point have to be? And that's right, 3 plus h in parentheses squared. Now, Ethan had said 3 plus x, and yesterday's lesson had that x in it. But because x already has a purpose, it's the variable that relates, y and x to create the parabola itself. The variable we're dealing with is h now, and we're going to end up with the slope of the secant line. This is review because we did this in the beginning of the year, but it's good review. So the slope of the secant line is 3 plus h squared minus 3 squared over 3 plus h minus 3, which you'll recognize from yesterday. And you could plug any value for h that you want except 0, because 0 makes it 0 over 0, which is undefined. So what we do is, instead, we say the slope of the tangent is equal to, and now we get to use the terminology, the limit, as we have to use h as our variable, not x this time. And that is going to get us the slope. We did this question yesterday. It became, you might remember, 6h plus h squared over h. That's the limit. H goes to 0, which became the limit as h goes to 0. It's annoying to keep writing limit as h goes to 0, but without it, it's not the same exact thing. And finally, you could put 0 in for h and get 6. So 6 is the slope of this line. Now that is a really specific question about the point 3, 9. But what if the point wasn't at 3, 9? What if it was at 1, 1 or 2, 4 or negative 4, 16? Well, we could redo this process over and over. Or we can go more generally. If I just call this random point x comma x squared, then the other random point on the parabola would be x plus h, would be x plus h, comma, parentheses, x plus h squared. And would you now take a minute to go through the slope of the tangent would be the limit, not as x goes to 0, but the limit as h goes to 0 of x plus h squared minus x squared over x plus h minus h. Well, this is going to be an answer in terms of x plus h minus x. So go ahead, simplify this thing, and we'll get like a general formula, which could be used to answer all kinds of questions without having to redo this process. So everyone take a minute. You could type what you're coming up with in the chat. Good, and I see what Talia wrote. She ended up with, after getting h goes to 0, 2xh plus h squared over h became limit as h goes to 0 of 2x plus h, which becomes 2x. So there is an x in the answer. Well, this is really useful because it means that as long as I know the x coordinate of the point on the parabola, the slope of the tangent line will always be double that coordinate. So here is the point, let's say -4, 16. According to this more general process, what should the slope of this tangent line be? In that case, you could type it in. Good, and I see -8. -8 is the answer. So the slope of the slope of the tangent lines on a parabola is always double the x coordinate, and we prove that by going through this process here. And if I come back to Desmos, we can see as I move this slider around, you can see that when a is 0, the slope is 0. When a is -1, the slope is -2. When it's 2, the slope is -4, -6, -8, and that's how it works with parabola y equals x squared. Okay, let's take a look at if we can do this for other functions. And we're going to skip to the general case for the rest of these. So here is the function. I can even write f of x is equal to x to the third power. Okay, now we have x comma x cubed is this point. This other point is x plus h is the x coordinate. Okay, would you take a minute or two to try to complete the process and see what the general formula is for slope of the tangent line to the curve y equals x cubed? Now, in order to do this one, you're going to have to remember from first semester binomial expansion, x plus h to the third power, which is, remember with Pascal's triangle, x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed. Those x cubes cancel out. And the denominator is h. So what ends up happening is that anything that has an h power that's bigger than 1, those are going to end up becoming zeros anyway, because even after I cancel out the h, there's still going to be an h there. Anything bigger than 1, h to the first power, is going to be sort of gone eventually. And all that's going to be left is the 3x squared. So for y equals x squared, the slope of the tangent was 2x. And for a cubic curve, it was 3x squared. So now I can answer questions like, for instance, what about the tangent line to the y equals x cubed curve at the point 1, 1, 1? What would the slope have to be according to this general rule about the x cubed curve? And yes, the answer is 3. 3 times 1 squared equals 3. Now I see a question from Talia. Is it possible to have a line? Well, the tangent is always going to be a line. The thing you're calculating here, this m, is going to be the slope of that line. So tangent itself is always a line. Do you mean, Talia, that can you do this for like y equals x? Because a line, the 3x squared is the formula for getting the slope. So you take the x coordinate of the point, square it, multiply by 3, and out comes not a line or a quadratic, but an actual number. That just a number. That 3x squared is going to turn into a constant once you plug something in for x.
Wait, so like 3x squared represents the slope of the tangent?
That's
like,
right.
Oh, I see. Okay, thanks.
And that is just going to become a number. But the way it changes, as you move along the curve, you are right that there's something quadratic where, like, the way that the slope changes is a quadratic equation. So there is something quadratic about it. And in calculus, you sometimes make graph of the way the slope changes, and it does become important so that it's quadratic. Now, let's summarize. For y equals x squared, the slope was 2x. And for y equals x to the third, the slope was 3x squared. Anyone want to speculate what it would happen if I made the power x to the fourth? And that's right, it would be 4x to the third. In general, the coefficient is the exponent, and the exponent is 1 less than the coefficient. I'll go like this. Y equals x to the n. The slope becomes nx to the n minus 1 power. That's only for things like of this form, where there's no number in front of the x. And the reason that happens is because no matter what the exponent is, there'd be some kind of binomial expansion. And that binomial expansion would always start off with x to the n, which would cancel out with the x to the n here. And the second term of the binomial expansion would be nx to the n minus 1h. And all the other ones would have h squared, h cubed. So when you canceled out the h, only that second term would be left, because plugging h equals, there wouldn't be any h left. So when I plug in 0, it's the only term that remains. And that's why that happens. This is like a major result from calculus next year. Your teacher's going to be all excited the day that they're going to be teaching that rule, the power rule, but you will have already learned it, so I kind of stole their thunder. Just act surprised when you hear it next year. Well, they're going to be mad at me. Okay, and the rest of this lesson is just going to be to do this for the other functions. So the other functions are y equals, what I'll always call f of x equals 1 over x. F of x equals square root of x. And f of x equals sine x. So I think I'll put you, even though there's only 16 people, I put you into 4 groups. That's the goal, to find the rules for these 3. So here's what the 1 over x kind of situation is. X comma 1 over x is the first point. Then over here, I have f of x is equal to root x. So this point is x comma root x. And then this other point, you talk about that. And then I have this one. This point is x comma sine x. And this other point. And I think I have one more. I have a 4th one, which is cosine. Yeah, that'll be a new thing. So this is x comma cosine x. So there are actually 4 questions I want you to work on. Let me put them all on one page. And see if each one's going to end up with an m equals, and it's going to be some equation in terms of x. And why not say, well, we'll plug x equals 2 into all of these also, so we get numerical answers. I'll say at the point 2 comma f of 2. So we're trying to find the slope of the tangent line. Okay, I'm going to put you into groups of 4. Now, I believe that this screen disappears when I do that. So if there's anything you need to write down to take notes of it, I'm going to give you some time. Okay, and now I'm going to put you into the breakout rooms. Let me pause the recording. Okay, everybody, can you see the iPad screen? Because I'm not able to, no, you can't. So let me go see what happens here. Okay, let's see if this works. Oh, you can see it now. And now I can see it also. Oh, they updated Zoom. I could actually go onto YouTube Live or Facebook Live. That's good to know. Maybe I'll do that. Experiment with that. Okay, you can see the answers here. So for 1 over x, it was minus 1 over x squared, or specifically when x equals 2, the slope would be negative 1/4. For radical x, it's 1 over 2 radical x. That one needed that whole rationalize the numerator thing from yesterday. And for the third one, sine became cosine, and cosine became negative sine. I'll show you the work for that one. So for the cosine, you would need the cosine sum formula. And then the cosine sum formula actually has a minus here, which is real convenient. Well, no, sorry, I said it's real convenient. It ends up becoming this minus here. These 2 terms get combined, and you factor out the cosine x, and you end up with this thing. That's something we just memorized. We memorized yesterday cosine x minus 1 over x. Well, it doesn't matter what you call the variable, so it's the same thing. That one goes down to 0 as h goes to 0, whereas this one goes to 1. The sine h over h thing can be explained graphically, that the sine, if I'm in radian mode, and this is theta, the arc would also be theta. So like if that was 0.5 radians, then this arc would be 0.5 units long. Well, the sine is this vertical line segment. And you can see that theta is always bigger than sine theta, but as we get closer, as that theta gets smaller and smaller, this tiny little arc is not much different than that vertical line segment. But when an angle is much bigger, theta can be a lot bigger than sine theta, but as it gets smaller and smaller, they both get really, really small. That's sort of informal explanation. Okay, now, I believe, I think there's a chance there'll be class. There's only one more live Zoom session like this, and it might be tomorrow because there may not be a meeting for me tomorrow, or it might be Thursday. I'm not sure. I have to make a decision. So I will, let's assume it's Thursday, unless, let's assume it's Thursday, unless I email you tomorrow, changing it to Wednesday. Okay, everybody. Anyone have any other questions before we end for today? Okay, so did I already close the recording? Let me see if I stop the recording. Stop recording.